Okay, here is homework 1 for dynamics in fall 2021. I've updated the problem a little bit, so you'll see that reflected on Blackboard. I'll send out an email and let you know. So we have experimental data of a particle was measured at the UHart laboratory and was curve fit. And they ended up finding that the velocity could be approximated by this equation right here. I won't read it out to you. Where v and t are in meters per second and seconds, respectively. And we'll also note that the particle starts at time equals 0 and x equals 3 meters. So we want to find the time when the acceleration is 0, the position the velocity when x is equal to 20 meters, and then c, the position, velocity, and acceleration when t equals 3 seconds. So some of this is actually fairly straightforward, but there's a couple snags along the way, which is really why they pay you the big bucks, right? To figure out how to do the difficult stuff. So here you go. Get the camera going here, and hopefully, let's see, it will. I should have started that before the video. Oh, there's some glue. No, that's not the camera we want. We want instead the document camera. Boom. Oh, and it's giving me that weird stripe thing. I hate that. I don't know why this does this. Something about this light. I think it's the bulb, this weird thing where it makes the stripes. So anyway, I'm going to move this over to my other screen here so I could read it and write down the thing. So normally I will probably write down the problem first. Let's see. I'm going to give it a page number. All right, so this is one of our first homework, so I want to make sure that I do all the things correctly. Let's put my name there at the top. Well, no, I'll put it over here, Dr. Deal. It's been a little while since I did these. Let's see. This is going to be homework 1, and this is fall 21 ES211, right? And this is problem 1, and we don't have to write down the entire problem statement, but write maybe just particle, right? Did I spell particle wrong? I did. That's sad. V equals 5 times t to the 3/2 minus 4t plus 2. All right, and we'll write down that we know at at t equals 0. Get it right. At t equals 0, we know that x is equal to 3 meters. And we need to put down the find, right? And writing these things down can help you as you're going along. You get your mind working and trying to inventory what's going on and start thinking about what our solution strategy is going to be. Turn your brain off. We want to find t at a equals 0. B, we want to find v at x equals 20 meters. I changed that to 20 meters. It was something that didn't make a lot of sense previously. And then we want to find, let's call it x. Well, I guess we're already calling it x. V and a at t equals 3 seconds. All right, so I already solved it in another sheet of paper so that I wouldn't sit here and ponder the thing. But let's describe our approach. All right, so this first one, we want to know time, right? And we have velocity as a function of time, so we could say that the acceleration is going to be dv dt, which is actually pretty straightforward, right? We just need to take the derivative of this right here. I'll go ahead and write it. d dt of 5t 3/2 minus 4t plus 2. Just come down to the next line, and the 3/2 drop down onto the thing, right? So that ends up making times 5, so it's going to be 15/2 times t, and we need to subtract 1 from that. That ends up being 1/2, right? And then minus 4, right? And then nothing, right? So there's the acceleration. And that's the acceleration as a function of time, right? And we can go ahead and solve it, right? We would say when this is equal to 0, right? We get 15 halves t 1/2 minus 4, or we could instead say, oh, I might have done something wrong here. Let me double check something. Okay, so I'm looking at my own paper and I messed that. That's what happens when you don't think, right? You just go into autopilot. So bring the 4 over to the side. We could say that t is going to be 4 times 2 over 15, all that squared, right? I think I got that right. Hopefully, I got it wrong on my other piece of paper there. So we can actually check this. I might do something in Excel to just demonstrate. So that's going to be the 8/15 squared, right? 8/15, and we're going to square it. And so we're going to see 0.2844 seconds is going to be what the answer is. We'll rewrite that at the bottom. That's the answer to part A. Part B is actually a lot more challenging. Let me see. Yeah, part B. I think what we have to do for part B to find the velocity when x is equal to 20 meters. What we ended up having to do for there, let's skip that one. Let's go to part C. I'll show you. If I had only asked this, that could be actually really challenging. But by having asked you for the other things in part C, that's going to help actually do the part B. It's going to help make it clear how to go approach part B. And we actually have to use an online tool or something to be able to solve that one right there. But let's go ahead. Let's say, okay, so the position, let's say we want to know the position. Well, actually, we could actually have plugged this 3 into here, right, and found the acceleration for part C. We can, for the velocity, we could just go ahead and stick this 3 back into the original right here and find the velocity. All right, so that was pretty easy. It's this position that we're going to have to worry about. Now, if we want to know position, but we have like velocity as expressed right here, what we want to do is maybe write velocity is equal to ds. I said ds, but everything else was x, so not s. Let's look at x, right? So let's go ahead and put this in the other way right here, right? Let's go dx. We'll rewrite it. Is going to be v dt, and we can integrate both of those, right? So let's write it down, and we're going to integrate x is going to be from this is going to be from 0 to some time, and this is going to be from 3 to some position. Now we have velocity as a function of time up here, so we can go ahead and put that in there. All right, so I'll even just finish this one off, right? That's going to be, oh, did I write that? Did I fix that over here? Let me double check something. No, we're good. We're good. Yeah, I think we're good. All right. It's going to be equal to the integral of 5t 3/2. I'll put parentheses around there. And then minus 4t plus 2 dt starting from 0 to t. That's supposed to be a t. Try to be a little neater. Okay. And so if you take that integral, just keep this thing over here for the moment. And we find that integral, this is gonna raise up by add 1 to this. That makes 5 halves. So we need to take 2 over 5. So it ends up being 5 times 2 over 5. We can see that those are going to cancel out, right? And then t raised to the 5 halves minus 4 divided by 2. So there's 2t squared. We're okay with that, right? And then plus 2t. And we're going to take this from 0 to t. So that's obviously, we could rewrite the whole thing. So here's the x is a function of time. It's going to be, I'm going to write this the right way, 2 times t to the 5 halves minus 2t squared plus 2t. Right. Now we can go ahead and plug in for time, right? So we go at t equals 3 seconds, right? We could say that position is going to be 2 times 3 to the 5 halves minus 2 times 3 squared plus 2 times 3, and we're going to end up getting, if I did it right, 22.18 meters. A little spider started crawling across there. We didn't get the camera, but that's good. And let's see, the velocity, it's just going to be the original equation, 3 halves minus 4 times 3 plus 2. And I said that ends up being a negative 4.804 meters per second. It's supposed to be a 4. And then the acceleration, we had that as a function of time up here. So we just have 15 halves and 3 to the 1 half minus 4. And what do we get there? We get an acceleration of 8.990 meters per second squared, right? Now we move on to this last part right here, which is B, the velocity when x is equal to 20 meters. Well, we don't have velocity as a function of position, but we can say, when does x equal 20 meters? We have this right here, so we could set this equal to 20 and find what time that happens, right? That's not necessarily obvious from the beginning, but as you move through, or you just try something or whatever, as you're approaching this problem, you're hunting and searching. If you get stuck somewhere, it's a lot like going through a maze, right? You want to go down a pathway, you get to a dead end, you got to circle back and come and look for something else, right? It's not always going to be a straight line to be able to get to the solution. So we could say that at x is equal to 20 meters, right? We could say 20 is equal to 2t 5 halves minus 2t squared plus 2t. And we want to solve for the time. When does this happen? Well, that's not an easy thing to do by hand. So let's go to our good friend Wolfram Alpha and try it out here. Okay, so I think I already did it, but let me... yes. So what I did was I typed in, maybe let's just go from scratch, right? We'll just go Wolfram Alpha. Wolfram, and you can see that I do it often, right? So there you go. Go to Wolfram Alpha and type in, first we have to make sure, I would point out that it'd be easier to bring this and collect it over to the other side. Wait a minute, I did something wrong. Did I do something wrong? I should say I might have done something wrong in my values. Let's see. Oh. When I was up here, I needed to bring that 3 over. Remember that right there. That should have been plus 3. Right? That 3 should have come over to the other side. So when writing this out right here, by the way, this is the correct value. I just forgot to write it down. So it should be 2 times 3 plus 3, right? All right, so that was my mistake. Sorry about that. But I do believe that's the correct answer. And then when we get to this one, let's plug this in. All right, so now we're going to bring, this is plus 3, so we're going to move this over to the other side. So it's going to be minus 17, right? So in here, let's see, am I in there? Yeah, okay. Just write 2 times t raised to the 5 halves, 5 divided by 2, right? Raised to that. And then minus 2 times t squared. Is that right? Plus 2 times t, and then a minus 17. And crunch, 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 crunch. It figures out, there's like a curve of it right here. But you see that it has a real root, but it also has 2 imaginary roots. Actually, it didn't even show it to me here. There it is. There's the imaginary roots, right? Well, the complex roots with imaginary numbers in there. So this is the only one that really exists, right? So the answer is, when does it equal 20 meters? It's when it's 2.85819, right? I only need 4 sig figs, so 2.858 is the answer. So for us, we write from Wolfram alpha, t is equal to, I wrote it down over here somewhere, 2.858 seconds. Therefore, the velocity, just plug it back into here, right? V is equal to 5 times 2.858, 3 halves, minus 4 times 2.858 plus 2. And that ends up equaling, if I did it right, and I think I did, 14.73 meters per second. So my answers A, I might not have enough room, unfortunately. Let's see. A is going to be, what do we find out? T is equal to 0.284. 3 sig figs is good enough for an answer. And box it. B, we're going to say V is equal to 14.7 meters per second. And C, and this will be several of them right there, right? So let's go position first. X is equal to 22.2 meters. V is equal to negative 4.80 meters per second. And A is equal to 8.99 meters per second squared. And we'll box that. I should use a straight edge for the box. But there you go. And this video might be too long, so maybe I should make 2 separate ones. Yeah, this video is too long, so I'll make 2 separate ones. So there was homework number 1, problem 1.